Hi, in this video we're going to look at how we can use Desmos to develop a function that models a series of raw data. So I've imported my raw data, I just copy and pasted it from Excel, and Desmos very nicely automatically put it into a table format and plotted my data for me. So I did a little bit of maths. I chose a turning point, so there was my lowest point, and I chose a point somewhere over here, and saw that my data basically followed a quadratic curve, a parabola. So I thought I'll use the turning point form, and I came up with a function like this, that y equals, with an a value of 0.4 times x minus 14 squared plus 4.2. So with a turning point at 14, 4.2. Now, I used approximately equals instead of to equals to, which then allowed Desmos to provide me with an r squared value. I'm not going to plot the residuals, we're just going to have a look at a couple of things. So this looks pretty good because my r squared value is pretty close to 1. It's 0.9083. But when I actually look at the plot that I've created from my function, I can see that it's not quite right. It's a little bit off. It's a bit over here to the left, my turning point, okay, it's fine, and over on the right hand side it looks pretty good. So what I thought I'll do is I'll have a look at how I can change this. So I typed in a function, leaving my vertical dilation as A, my horizontal shift as B, and my vertical shift as C, and left sliders for that. So I've done that and I've typed in the values that I found. So this is what it looks like, identical. Okay, now what do I need to do with this? The first point, I can see that is my whole function is a little bit to the left, so I'm just going to shift it to the right. So remember, the B value is my horizontal shift. I'm just going to move that a little bit to the right, and that's looking pretty reasonable. I can see that there's a relatively similar distance on the left hand side from my raw data to my function, and the right hand side to my raw data and my function. But the shape of my curve is too flat, so I need to dilate it in the y direction. So I'm just going to increase my a value. Whoops, too far. Let's take it back. And that's looking pretty good. So you can see the red was my original function that I developed. Now with my sliders, I've adjusted this. Now what I'm going to do is I'm just going to move it back to what I had. So that was 0.4 and that was 14. So it's still my other function. And I'm going to put in an extra column up here. I'm going to look at the difference, and I'm going to square it so that it's all, I have absolute values between my raw data and the data that my function has produced. Now, if there was no difference between those two, then the value would be 0. And you can see that I'm pretty far off here. So let's just plot this and have a look at what it looks like. So these purple points are the points, the matching between my raw data and my function. So now let's go back and move our sliders to what we thought looked like a pretty good fit. So remember my A value, I needed to flatten that out a little bit. Flatten it, stretch it in the Y direction. So I move that up to 0.5. Okay, it's not looking too, my purple dots need to, remember, they need to be down here to 0, they need to be as close as 0. Okay, but we also had a look at our B value. We shifted the whole function to the right. And you can see as I'm doing that and getting close to there, that's looking, whoops, let's take it back to 15, that looks pretty good. That's looking pretty good, that the difference between my raw data and my function is looking great. So it's a much of an improvement on my original function that I developed. So that looks pretty good. I'm going to hide all of this. Actually, I'm just going to delete all of this. And what I can also do is, so we had our function and we tweaked it, but we can also get Desmos to develop a function for me. for us. Now we still need to be able to do the math, so this is just another little checkpoint that we can do. So what I'm going to type in is I'm going to go y1, which is my y value, is approximately equal to an a value, which is my vertical dilation, x1, that's my raw data, so I'm choosing y1 and x1 because that's what I've labelled my data up here as, minus b, close my brackets, this is squared, that's my turning point form, plus c. And there it is. Desmos has now modelled a function. The r squared value is very close to what I had with my altered function. I've got to show you that, but if you zip back you'll see that it was 0.999. And my parameters, my a is very close to the 5 that I had, b is very close to the 15 that I had, and c is raised a little bit high. So it's a little bit different from my function, but also very similar and has given me an excellent r squared value, a correlation coefficient. I could also type this in standard format and get my quadratic function in standard format as well. So there you have a couple of options on how to use Desmos to have a function and use your sliders to tweak it and check it with your residuals, or to use Desmos to develop a regression for you.